The answer is that in Sibiu, the action function gives us 4 actions corresponding to traveling along these 4 roads. So we have to add in paths for each of those actions. One of those paths goes here, the other path continues from Arad and goes out here, the third path continues out here, and then the fourth path goes from here, from Arad to Sibiu, and then backtracks back to Arad.
There are 4 possible actions to take from Sibiu: the path to Oradea, the path to Phagros, the path to RV, and the path back to Arad. Because Arad is already expanded, we cannot take that action in the graph search.
Now it may seem silly and redundant to have a path that starts in Arad, goes to Sibiu, and returns to Arad. How can that help us get to our destination in Bucharest? But we can see, if we're dealing with a tree search, why it's natural to have this type of formulation, and why the tree search doesn't even notice that it's backtracked. What the tree search does is superimpose on top of the state space a tree of searches. And the tree looks like this. We start off in state A, and in state A there were 3 actions, so it gave us paths going to Z, S, and T, and from S there were 4 actions, so that gave us paths going to O, F, R, and A, and then the tree would continue on from here. We take one of the next items and remove it and continue on. But notice that we returned to the A state in the state space, but in the tree it's just another item in the tree.
This figure shows a tree structure. The root is the node A. It has 3 children: node Z, node S, and node T. Node S has 4 children: node O, node F, node R, and node A.
Now here's another representation of the search space. And what's happening is, as we start to explore the state, we keep track of the frontier, which is the set of states that are at the ends of the path that we haven't explored yet. And behind that frontier is the set of explored states, and ahead of the frontier is the unexplored states.
This figure shows a tree structure. The root is A. A has 3 children: Z, S, and T. S has 4 children: O, F, R, and A. R has 2 children: L and P. P has 1 child: B. B has 2 children: G and U. L has 1 child: M. M has 1 child: D. Now the frontier contains O, F, R, A, and L, and the explored set contains A, Z, S, and T. The rest are unexplored set.
Now the reason we keep track of the explored states is that when we want to expand and we find a duplicate, so say when we expand from here, if we pointed back to state T, if we hadn't kept track of that, we would have to add in a new state for T down here. But because we've already seen it, and we know that there's actually a regressive step into the already explored state, now, because we've kept track of that, we don't need it anymore.
Assume L has another child T. Because T is the parent of L in the tree, we do not explore T from L.